Today we are doing polynomial long division. This is going to be section 6.4. This is surprisingly useful in a lot of crazy ways, in a lot of different ways too. And sometimes it just pops up out of nowhere and you're like, oh, I have to do this. And so it's really good to be able to do this stuff. And we're going to spend some time doing it. But before we do that, let's just do some regular old long division to kind of refresh our minds of what long division looks like, right? So let's say I wanted to divide two numbers. And let's say I'm using 841. I want to divide that by 4. If I did that, we could do long division, right? And I assume you've done long division before. And when I write this, you know what I'm doing here.
Oh gosh, I haven't done this in forever. But
right?
yes.
Okay, but as we go along, you'll see. So what do? What's the first thing we do? It has something to do with these two numbers.
You multiply 4 by however many, it goes into 8, and then put that number above the 8.
That's how I think about it. That's exactly how I think about it. And that's how we're going to think about this for the rest of the day. In other words, what number do I need to multiply 4 by in order to give me 8? What number is that?
2.
2. So I put a 2 right here. And then I do that, right? Then I say, okay, 2 times 4 is 8. Then what do?
Then you subtract it.
I subtract, right? I take this number, whatever it is, and I subtract it off. Now watch what I'm about to do. I'm going to put parentheses around here.
Oh boy.
What's about to happen is this is going to get much more complicated. And just throwing a minus sign in front of something, it just symbolically, it's weird. But what can help keep you straight is putting parentheses around the number you're about to subtract and then putting a minus sign. That will help you. Trust me on this. You want to do this. So we take 8 minus 8 is gone, right? That's kind of the idea. We're trying to get rid of it as best as we can. Then what do?
Then you put a 0. And then you have the 4 and the 1.
And they drop down, right?
Yeah.
That's how it's usually set. The 4 and the 1 drop down. I'm not going to write the 0 for the 8. I'm not going to write any zeros. Well, we're going to write some zeros today. But the thing cancels itself out. And with polynomial long division, that's always going to be the case. It's always going to cancel out exactly. And when that happens, I'm not going to write anything down. Then, okay, the 4 and the 1 drop down. Now what do?
Then you get the 4 into the 4 and you get a 1 on top.
1 on top, because we're thinking, okay, what number times 4 gives me a 4? Well, 1. 1 times 4, and notice what I'm doing, right? This is gonna be important. I take this number, multiply it by this number, whatever it happens to be, and then I put it down here. So I go 1 times 4 is 4. I put that down there. Now I'm going to take whatever number that is, parentheses, subtract him off. I get 4 minus 4 is 0. The 1 drops down, and I'm left with a 1. Now what would we do in polynomial? Regular long division. What?
Pretty sure you would put like a decimal point. No, wait. Yeah. And then a 0.
There's a couple different steps you could take at this point, but that's
I think I just learned that you just like take more zeros.
Yeah, exactly. Because think of what we've done, right? We said that a 2 goes in the hundreds place, a 1 goes in the tens place, and now we're in the ones place, but we don't have a 4. We don't have anything bigger than a 4. And so we're going to have to go down a step. And so, yes, we could do this. This really isn't that important because it's going to be different in polynomial long division, but just to refresh ourselves, right? say, well, we're in the ones place. We don't have enough to go there. So we go 0 decimal point like that. And then we drop a 0 down. Because those zeros are always there, right? Any number, 841 is 841.0. It's actually 0.000 and so on to infinity. And so there are as many zeros as we need to drop down. In this case, we only need that guy right there. Now we have 4 and 10. So what do I do?
You take 4, multiply it by 2.
So I'm going to put a 2 right here. 2 times 4 gives me what?
8.
Yeah, and so I go 2 times 4 is 8, and I put it in this place right here. So that 8 shows up here.
No.
I'm
And
going
then you subtract.
him off. 10 minus 8 is what?
2.
It is 2. And now we're kind of in the same place as before. And it's like, well, I have infinitely many zeros to drop down. 4 does not go into 2, so I need an extra 0. Now I have 20. 4 and 20.
You put 5 up top.
Put a 5 up top because, in other words, what I'm asking myself is, what number do I put right here? So what number times 4 gives me that number? That number is 5. 5 times 4 is 20. And so I put a 20 right here. Parentheses, I'm going to subtract him off, and we have a remainder of 0 now. And what we've just found is that that number divided by that number is 210.25. So I'm going to go ahead and erase this right here and write that out. Hey, buddy. 210.25. Now, another way we could have done this, here you go, buddy. And this, you might think, oh, this is what we'll be doing with polynomials. Not really. Like, only in very special cases will we do what I'm about to do with polynomials. But sorry, he needs a hug. Come here, buddy. Give me a hug. Love you. What we could do is say, well, let's just rewrite 841 as 800 plus 40 plus 1. And then take that and divide it by 4. In which case we would have, well, we could split this up into 3 fractions, right? Because we have a common denominator. I'm just going to go ahead and do it. Then we're going to look back at it and see if what I do is valid. I could say, well, this is just this, right? Because if I have a common denominator, I could split up the numerator, because this right here, we all have a common denominator. And if I started right here, if I gave you this, what you would do is say, well, I have a common denominator, so I'll put everything over that common denominator, and then I'll just have what's in the numerator as that plus that plus that. Looks valid. Now check this out. What's 800 divided by 4?
200.
200. What is 40 divided by 4?
10.
10. What's 1 divided by 4?
0.25.
0.25. Oh, hey, look, math is consistent. This works. 200 plus 10 plus 0.25 is exactly the same thing as that. Now, what we're going to do, so one final thing to note. That the reason that the long division algorithm works, the first thing that we did, is because technically this is what you're doing. And this is what I kind of want to get into right here, is when we initially have 841 and we write it like this, what we're doing is we're actually treating it like this. Because remember, the first case we said, well, we say, how many times does the 4 go into the 8? And you say, well, it's 2, right? 2 times 4 gives you that. But when you put it in the place like we did, right? We had 4, 8, 4, 1. and you say, well, I'm going to put a 2 here above the 8. Well, that's because the 2 is in the 100s place. Just like we said earlier, 800 divided by 4 is 200. Well, that's what we're doing right there, right? We're saying like that is a shorthand. This is kind of like the lazy way of doing this right here. And this is why this algorithm works. Then you say, well, 200 times 4 is 800. And so then you subtract it off. And you've taken that whole sum minus one of those, and you're left with plus 40 plus 1, just like we did here, right? The 8 came down, we subtracted it off, dropped the 41. Get rid of this guy. And then we just keep going on. Now it's like, okay, I have a 40 left over. 4, how many times does 4 go into 40? Or rather, what number do I multiply 4 by to give me 40? Well, it would have to be a 10, because 10, then I take this number, 10 times 4 equals 40. And then I take whatever I put down here, subtract him off, and I'm left with 1. And what we're going to be doing is, instead of finding a decimal, because there's no decimals with polynomials, what we do is when you're down to a remainder, you just say, well, it's whatever this is plus this number over that number. And we saw that earlier, right? We said 8, 4, 8, 40, and 1. When you divide them each by 4, what was left but the quarter? In other words, the number that's going in the denominator, this number right here, shows up in the denominator. And what do you know? There's 1 left over. So we could write this as 200 plus 10 plus whatever the last thing is, divided by whatever that thing is, 1/4, and we would have our answer right there. It's why the polynomial long division works. And we're going to use that only now with, that's why the long division algorithm with regular numbers works, is because you're doing this, but we just simplify it by saying, well, this goes in the hundreds place. And so you know that that 2 actually has 2 zeros along with it, and so on and so forth. So, okay, one last thing. What we could do with each of these, now that we've figured this out via polynomial long division, or we figured this out via long division. One final thing we could do, and I'm going to be doing this a lot, so pay attention to this step I'm going to do right here, is I could say, well, in order to check that I got the right number here, what could I do?
You could multiply that number by 4.
Exactly, right? I claim that this divided by this equals this. Well, then if I multiply both sides of this equation by 4, right? I bring him up into the numerator. Then this should equal that. And so let's just check it real quick. 210.25 times 4. 4 times 5 is
20.
Carry the 2. 2 times 4 is
8.
Plus 2.
There's 10.
Carry the 1. Drop the point. I'm going to go ahead and drop the point. 4 times 0 is
0.
Plus 1 is
1.
4 times 1 is
4.
4 times 2 is okay. And so yes, we can see that yes, this does work out. Oh, that's what this means, right? That divided by that gives you that. Means exactly the same thing as this times this equals that. Okay. A lot of review, a lot of boring stuff. Now let's get into new stuff. So the first thing that your book goes over, and we're just going to go ahead and do it too. This is not, there are certain cases where you don't need to use the actual long division algorithm for this. For instance, if you have something like this, 24y to the 6th, plus 18y to the third minus 36y squared. And we want to take that number and divide it by 6y squared. In this case, we could just split this up the same way I did earlier when I split up the fraction. I could just say, well, this is the exact same thing as, and notice, I'm dividing by a polynomial with only one term, right? Where it's going to be much different when you have more than one term down here. And that's where the polynomial long division is going to come in. But when you only have one term, this is pretty simple stuff. We could just say, well, this is the same thing as 24y to the sixth over 6y squared plus 18y to the third over 6y squared plus 36y squared over 6y squared. Now you tell me, what is this first one equal to? What do I cancel? What does it end up being?
Hold on. You can multiply the top by 8.
Wait, first off, let's do the numbers. What's 24 and then over 6? Can we simplify that guy?
Yes.
What is it equal?
Wow, my brain is like.
That's all right. 24 is 6 times some number.
4.
It is 6 times 4. And so 24 divided by 6 is the same thing as 6 times 4 divided by 6. So the 6's cancel, and I'm left with only a 4. Okay. What's y6? Y to the 6th over y squared.
Y to the 6 over y squared is
it's 4.
Hey, Jason.
4xp minus 7 over 4. I'm kidding. I don't know what you're talking about.
That's all right.
It's nice to see you. Thank you for all your help.
It is good seeing you too, man.
Okay, you guys math away.
Okay, we're mathing. We're mathing.
right.
When in doubt, right? Just think visually. Y to the 6th means y times y times y. You have 6 y's in the top. Y squared means you have 2 y's in the bottom. How many of those y's cancel out?
Both of the 2 y's on the bottom. So you have 4y, or y to the 4th.
Y to the 4th on top. There we go. All right, using the same reasoning, what does this guy come out to be?
Okay. 3y.
Y, right? Because so as I'm looking at this, what I think is, well, 18 divided by 6 is 3. So get those out of there and write it 3. 3 y's on the top, 2 y's on the bottom leaves me with 1 y. Now, finally, what do we have here?
6.
Just plain old 6, because 36 is 6 times 6, divide by a 6. There, 2 of them are gone, leaving 1 in the top. 2 y's in the top, 2 y's in the bottom. The y's are gone, and that's what we have. So that's all that is. We're not doing anything fancy there. If you have a monomial, that is, you're dividing by something with only one term, it's super easy to just break this apart. And I think in your homework, every time they do that, I can't see a contradiction to this, that they're all divisible by something. You don't end up with any fractions. But if you did, it's not the end of the world, right? Like if, for instance, I just want to say, if that were a 3 right here, 23 is a prime number, I think. And so 23 divided by 6 is already as reduced as it gets. And so in that case, you'd say, well, 23 divided by 6 is 23 divided by 6. we have 6 y's in the top, 2 y's in the bottom. That leaves me 4 y's total. So I would just write that as y to the 4th right there. And so, although I don't think they've given you anything like that in your homework, but that's what you would do. You're simply reducing stuff, canceling stuff on the numerator and denominator. There's nothing nothing tricky about this. So when you have a polynomial and you're dividing by a polynomial with one term, just split it up and cancel stuff in the numerator and denominator. So moving on. Okay. However, when we have more than one term in the denominator, now let's do something that we actually know how to do. So for instance, we know that x plus 1, x plus 2 divided by x plus 1, what does that equal?
X plus 2.
Just x plus 2, right? And so what I'm going to do, we're going to verify this. Well, first I have to explain the algorithm to you, right? But we're going to start with something that we do know. Like I'm 100% certain that this is true. Okay. So let's multiply out the top. What is x plus 1 times x plus 2? Let's multiply that out. Tell me what to write.
X squared.
Yep.
Plus 2x. Plus 1x. Or just x. Plus 2.
Plus 2. So altogether we have x squared plus 3x plus 2. So I'm going to just rewrite this right here. X squared plus 3x plus 2. So if we had that, now, we know this is true. We know that when I take that and divide it by that, I have to get this polynomial right here. The problem is, if I were to do the same trick, don't write this down. If I were to do this trick, x squared over x plus 1 plus 3x over x plus 1, if I tried the same trick that I did a second ago, well, what is that? I have no idea what that is. I can't cancel anything out. 3x over x plus 1, nothing cancels, nothing cancels. Now I have this ugly thing, and it doesn't get me any closer to what we know is the answer. So here comes polynomial long division to the rescue, right? What we're going to do is say, well, the same way that we did before, right? We could kind of think about this as like, well, that's kind of like my hundreds place. That's kind of like my tens place. And this is kind of like my ones place. And we could play that same game that we did, where we said, well, we'll just write this thing like this, just like that. And now over here, what we're dividing by is x plus 1. So I'll do that. Now what we're going to do. So step 1 is to rewrite your stuff like this and make sure that your polynomials are in descending order. Just like when we wrote everything with regular numbers, we had to have the hundreds place all the way to the left. We had to have the ones place all the way to the right. And yeah, that has to be consistent for this to work. So our polynomials are in descending order. And now, instead of looking at this entire thing here, all we're going to do is just look at the first term. In this case, it's just an x. So what times x gives me an x squared?
X.
Just x. Right? So it's the same exact question that we were asking when we were doing long division. When it was 804, we said, what number do I multiply 4 by to give me 800? And we said, well, it's 200. In this case, I know what I'm about to do. I'm about to write a number here to subtract that guy off. And so whatever this guy is, x squared, he's the guy who needs to go away. And so I ask myself, what number do I need to put above him so that when I multiply him by this first term, which is x, it gives me an x squared. You just told me that's an x. Okay, so I do that. Now, this is where it gets tricky. And I'm going to say my first step, what I like to do is write my parentheses just under it like this, because I don't want to forget about my parentheses. Now, instead of just, it was easy when we had one number on top and we were multiplying by one number over here, right? Like when we did this with 4 earlier, it was written as just one number. And so when we put our 2 right here, we had to multiply by 4, right? And that gave us 8. But kind of what's going on here is now that one number is split up into 2 numbers. It's like as though I had rewritten my 4 as 3 plus 1 over here. And so what I would have to do is, we know that before we were trying to get an 8 right there. And so I can't just multiply this 2 by that. I have to distribute the 2 into both of them, right? The 2 has to jump down and hit the 3 to give me a 6, plus a 2 times the 1 is a 2 to give me my total of 8. That's the same thing we're going to do right here. We're going to take that x and distribute him into this x plus 1. So let's do that. The x jumps into here and gives me what?
X squared.
Squared. Then he jumps into here
X.
to give me x. And so, and this is going to be really important. It's a plus x, right? Because it's a plus 1. So it's going to be a plus x. So I'm going to go plus x. And look at how I'm writing it in this nice little column right here. Oh, there's a nifty column. You probably want to keep those together. So now I've taken that x and I've distributed it into the entire x plus 1 thing. Oh, okay, buddy. So I'm going to close my parentheses now. Just like that. And now I'm going to subtract it off. So I'm going to put my line right here and write a minus. Now, this is why I really suggest using parentheses. Your book does not do this, but trust me, you want to. This just helps to remind me that that minus has to distribute into here and into here. Okay, so we're going to subtract this off. The x squared minus x squared gives me a 0, because that's why we chose the x in the first place, right? If you're doing this and you get to this point and you get anything that's not 0, you did something wrong, okay? Because that's the whole point. We're trying to cancel this thing out, and so that thing better cancel it out. And in this case, it does. So there's a 0. I'm not even going to write it. Now I'm going to move over. I have 3 x's. Now that guy jumps over minus 1x gives me what?
2x.
2 x's are left over. And just like we did before, we're going to go ahead and drop the 2. The 2 comes down. So plus 2. Now it's the exact same game. I'm going to say, okay, what number? And again, I'm only looking at this leading term here. I'm going to say, what number do I have to multiply this guy by in order to give me this thing right here?
Two.
2. Exactly. Is it positive or negative 2?
Positive.
Positive 2, right? So plus 2. Now let's do it, right? I'm about to take this and distribute him into each of these. So the 2 jumps into here and gives me 2 times x is
2x.
4x, yeah, and don't forget your parentheses, so positive 2x. Then the 2 jumps into here and gives me what?
A plus 2.
Plus 2, right there. I'm done. I've distributed him all the way in. And so I'm going to close my parentheses. Now take that, subtract it off. And I really don't need to use my brain for that. I could see that's the same thing as that. If I subtract off that entire thing, I should get a big fat 0. And so what we just found was that this polynomial, right, the x squared plus 3x plus 2 divided by x plus 1 is equal to x plus 2. And if we are so inclined, I'm going to go ahead and erase this. You got all this right here?
Yeah.
Okay. So if we were so inclined, we could check this by saying, well, just like we did before, right? We took 841 divided by 4, and so I brought the 4 up into the numerator and multiplied them through to check. And so let's go ahead and do that. We get x plus 1 times x plus 2. That's exactly what we did right there. So this is kind of silly, but we get x squared. Outer gives me 2x, inner gives me 1x, so for a total of 3 x's. Then 1 and 2 gives me 2, and I can see, yes, that works. Check, we're good to go. That is how polynomial long division works. Let's do some other examples. Any questions before we go on?
I don't think so.
Okay, so number 12. They say to compute. This is another one where we're already going to know the answer, but we want to do this with the algorithm to verify. So number 12 is a squared minus 81 divided by, and they, in each one of these in your book, they have it as, they have a divide sign. I don't think about it that way. I don't like it that way, but they have the a squared minus 81 divided by a minus 9. I hate that sign. I think of this as that right there, and that's how I'm always going to write it. So anyway, let's see if we could figure out what this is just by factoring it. Can we factor the top?
It's a plus 9. 4 times a minus 9.
A minus 9. And
And
so
then cancels, and it's a plus 9.
it should just be, if everything's consistent, we should be able to use our polynomial long division to take this, divide it by that, and we should get a plus 9. Let's see if it works. Now, here's the tricky thing, and this is what you're going to need to keep in mind here when you do this, is, okay, I'm just going to go along and say, okay, we're dividing something by something. That's the sign I use. The thing that we're dividing by is a minus 9. Okay, and the thing that we are dividing is that, a squared minus 81. Problem is, we have to account for all the things that aren't there. So what I'm going to do is, instead of just writing a minus 81 right here, I don't want to do that. I want to account for the fact that there's not an a term. So I'm going to write plus 0a and then minus 81. So long story short, if we had something like a to the 5th minus 1 over a plus 2, we would have to rewrite this thing as a to the 5th plus 0 a to the 4th plus 0 a to the 3 plus 0 a squared plus 0 a minus 1. You want to account for every term that's not there. Does that make sense?
Uh-huh.
Okay. Okay, so, okay. What number do I need to multiply this guy by to give me this guy?
A.
A. So I'm going to put an A right here. Now I'm going to distribute that A into this polynomial right here. The A times the A gives me what?
A squared.
It had better give me a squared, or I've done something wrong. Okay. And then look, my parentheses. Now what? Then what do I put?
Minus 9a.
Minus 9a. I'm going to end parentheses because I'm done distributing into my polynomial. Now I'm going to draw a line and subtract. The a squared minus the a squared gives me 0. It had better, right? That's my check on myself. Like if I get to this point and that doesn't come out to be 0, I did something wrong. So that is gone. Now what? What do I do here? What am I left over with?
You add them.
Mm-hmm.
You have 9a. Or positive 9a.
Positive 9a. There you go. Right, and this takes care of that ambiguity, right? So I don't have to worry. Wait a minute. Whoa, minus a minus. Yeah, you're minusing a minus. That's what's going on right now. I don't have to second guess myself. So I take 0 plus 9a gives me 9a. I'm going to drop to 81. Now, what number do I need to multiply this guy by in order to give me this guy?
9.
9. Positive or negative 9?
Or positive.
Positive 9. Okay, now I'm about to do some multiplication, so I'm going to put a parentheses. Now the 9 jumps into here and gives me what?
9 times the negative 9 is a minus 81.
Yeah, but what's the first thing that happens?
Oh, it multiplies by the a. Sorry.
Yeah. You know,
9a.
so we get 9. And then what?
And then you get the negative 81.
Negative 81. Negative 81. I end parentheses. Now I'm going to subtract this off. Lo and behold, there's no remainder because 9a minus 9a is 0, and negative 81 minus negative 81 is a 0. And so we just found that, yes, indeed, that divided by that is equal to a plus 9, which we already knew. But in your homework, like the whole point of this is to get familiar with this algorithm, right? To do the long division. So in every one of your homework problems, you're going to be doing the polynomial long division. Just like this. If there are missing terms, you put them in as 0, right? And then you just pop it out. And if we were so inclined, we could say, well, this divided by that is that right there. And then we could double check it by multiplying that guy by that guy, which indeed gives me a squared minus 81. Okay, let's do a couple more examples where things get a little tricky. Oh man, that's ugly. I don't want to do that one. I was going to do that one. I really don't want to do it. So let's do this one. X squared there, and there. That should do. Okay. All right. Am I ready to erase?
Yes.
Okay. So far, we have seen stuff without remainders. Let me show you what we do when we do get a remainder. And I believe if I've done this right earlier, this should give me a remainder. So x cubed minus x plus 6 divided by x plus 2. Okay, so I have a polynomial with multiple terms divided by a polynomial with multiple terms. So I've got to use my long division thing. And so what do I write under here? You tell me what to write.
X to the third minus x plus 6. No? Oh, right. Do the weird thing. Plus 0x squared.
There you go. Now
minus x plus 6.
plus 6. There we go. Guys, just like, and it's just like if we were going to divide a number, you know, if we had two numbers like 2012 divided by 7, we wouldn't write that. We would have to account for this because this is 2000 plus, well, 0, but plus 10 plus 2. And as we go through and do this, like that guy does come into place. There is a placeholder for him, right? As we go through and actually do the long division here, right? Like if we just truncated him and said, well, bring these guys over, well, now you're not working with the same thing anymore. Like
Right.
you have a placeholder. And the numeral system does that. It gives you a placeholder by calling that a 0. But this guy, we have to account for that missing place right there with an actual term that does not exist. Well, that is not written there. So okay, we're dividing by x plus 2. Okay, so what do I put above the what do I put here? What's first?
So you multiply by x squared, I think.
Yes, because x squared is the number I need to multiply this guy by to give me that guy right there. So I do that, and what do I get? X squared times x is x to the third. It had to be. Okay, now what?
You have 2x squared.
Plus 2x squared. Now we can see why that placeholder is so important. Actually, it's not deathly important, but it will make your life so much easier. So I'm going to put my parentheses, subtract them off. What am I left over with?
Minus 2x squared.
Minus 2x squared. Now I'm going to drop the other guys here. Drop everything down. Now, what do I need to multiply this guy by in order to give me this guy right here?
Minus 2x.
Minus 2x. There we go. Minus 2x. Now I do that. I'm going to go ahead and put some parentheses out so that I don't screw up. Minus 2x times x gives me minus 2x squared. As well it should. That's the whole reason we put them up there in the first place, so that had better work. Now what do I do?
Multiply the minus 2x by 2, so you'd have minus 4x.
Minus 4x. I'm going to put him under the x's column. End parentheses. Draw my line. Draw my subtraction sign. Now the subtraction jumps over and kills that first thing that had better come out to be 0. Now what?
So then you subtract 4x from x minus x and you get minus 5x, I think. No.
Parentheses, and there's a minus out there.
Right, plus.
Jumps in.
So you'd get plus 3x.
Plus 3x, because this means minus a negative is the same as plus a positive. So
Right.
Plus 4x minus x does give me indeed 3x, positive 3x. And then what do I do?
Then you drop down the 6.
Drop down the 6. Now, oh, this doesn't work out. We're not going to get a remainder here. What do I multiply this guy by in order to give me this thing right here?
The plus 3.
Plus 3. And it works out. Now, you tell me what to do. I have my parentheses ready to go. 3 times that gives me what?
3x.
And then we distribute him in and we get what?
6.
Plus 6. Then when I subtract that guy off, the 3x is gone. As well, he better be. That's why we chose the 3 up there in the first place. And now we can see, okay, oh, the 6 minus the 6 does end up being 0. And so we end up with this thing divided by this thing is equal to that thing right there. And we get x squared minus 2x plus 3. Am I good to erase all of the work right here?
Yes.
Okay, I'm going to erase that. Now let's just check it. Let's see what happens. Okay, so we're checking it by saying, we took something divided by something gives me this thing. So if I multiply him up here, it had better give me the original thing. So x plus 2 times x squared minus 2x plus 3. Now let's distribute this guy in here first. So we're going to go the x's jump in first. X times x squared is what?
X to the third
Okay, x times minus 2x.
is minus 3x.
Wait.
Wait, x
Times that.
minus x squared. 2x squared.
Minus 2x squared. There we go. There we go. Now the x jumps over and hits the 3 and gives me what?
Plus 3x.
Plus 3x. Okay, now we've done the first distribution. Let's distribute that second number. The positive 2 jumps in. And first gives me what?
2x squared.
2x squared. So I'm going to write him under the x squared column. The 2x jumps in and hits him and gives me what?
Minus 4x.
Minus 4x's. Finally, the 2 jumps in and hits him and gives me what?
Plus 6.
Plus 6. So I'm going to add all these guys up. X cubed stays x cubed. A minus 2x squared plus 2x squared is gone. I get a big fat 0. 3x's minus 4x's gives me minus 1x. Nothing plus 6 is plus 6. And I could see that, yes, this thing times that thing is equal to my original thing. That is x cubed minus x plus 6. So, okay, I did this one earlier and thought that this was the one that ended up without a remainder. Sorry, I just went ahead and erased all that. Hope you're done. But I was wrong. We need one with a remainder. That guy has a remainder. Ooh, that's a good one. So we're going to divide that by that. So this one more example, and then we should be done. So minus 9x squared minus 5 divided by x minus 2. Okay, we have a polynomial divided by a polynomial with more than one term. So we got to use our polynomial long division. Okay, so what do I write under the divide sign?
X to the 4th plus 0x cubed minus 9x squared plus 0x
Yep.
and 5.
Minus 5. So that's good, excellent, right? And we're thinking starting, and just another thing I haven't been stating, I said it once, but it's really important that the terms are in descending powers of x. That is good. They need to be. Okay. So, okay. On the outside, what do I have?
X minus 2.
Okay. And so what number do I need to multiply this guy by in order to give me this guy right here?
X to the 3rd.
X to the 3rd. And so when I do that, I get what?
Okay.
Okay.
You get x to the 4th
X to the 4th.
plus the minus 2x to the 3rd.
Minus 2x to the 3rd. Good. Excellent. And so, yeah, that guy jumps in, hits them, that. And so now I put my parentheses and I'm going to subtract them off. The x to the 4th is gone, as well it should be. And what do I have left?
You have a positive 2x to the 3rd.
Good. Positive 2x to the 3rd. And now I usually don't rewrite these by dropping them down. I'm lazy and I just look up above as I do it. But anyway, yeah, I'm gonna go ahead and rewrite it. Okay, now, what number do I need to multiply this guy by to give me this leading term right here?
2x to the second.
So plus 2x squared. Okay, let's check and see. And this is what's nice about this is you could just guess, like you could just look at it and be like, well, especially when they start getting complicated and if there are fractions involved and stuff, you could just say, I think it's 2x squared. Let's see. I'm going to put a 2x squared right there. And now here's where the truth comes in. If you were right, then it should give you exactly this thing right here. So let's just check it. The 2x squared hits the x and gives me what?
2x to the third.
There we go. And then the 2x squared jumps in and hits the second term, or the second bit.
Minus 2x squared. 4x squared is what I meant.
Go. Good. Now when I subtract it off, I can see, yes, the 2x cubed and the 2x cubed are gone. And so now I can feel confident that, yes, indeed, I did write the correct thing there. That's nice. So now what do I get here?
You get minus 5x squared.
Minus 5x squared. And to be clear, the reason why is because we had a minus 9x squared. Minus a minus is plus a positive. So we had minus 9 plus 4 gives me minus 5. So we're good. So now I'm going to drop the other terms. I get a 0x and I have a minus 5. Okay. Now, what do I multiply that guy by in order to give me that guy right there?
A minus 5x.
Minus 5x. And when I do that, what do I get?
Minus 5x squared plus 10x.
Plus 10x. And I'm so sorry that I'm running out of room. Ugh. Okay. So when I do that, now I'm going to subtract that off. And what's the first thing that happens?
Get a 0.
That guy's gone. So we did the right thing. Now we have that and that. What do I get?
Minus 10x.
Minus 10x. Good. So I'm sorry. I'm just going to go ahead and write that up here. On your paper, you should be able to keep tracking and everything.
Yeah.
So, okay. Minus 10x is what's left over. Minus 10x. And then the minus 5 is going to drop down right here. Okay, so he's right here. I'm imagining him right there. Now, what do I need to multiply this guy by in order to give me that right there?
Minus 10.
Minus 10. And when I do that, what happens? Jumps over and does what?
It has a minus 10 next to the minus 10x and then a minus plus 20.
Okay, so I'm going to make sure I do my parentheses first. And you said the minus 10 hits the x and gives me minus 10x. And it had better give me minus 10x or I did the wrong thing. Then he distributes over and you said that gives us plus 20. Okay, plus 20. Now I subtract it off and what do I get?
You get a minus 25.
Minus 25 is my remainder. So I'm going to actually get rid of this right here and just put that right down here. Minus 25 is the final remainder here. Now, we could say, if we were just continuing on, we could say, well, what number do I need to multiply this guy by to give me that right there? And you could say, well, negative 25 over x. And you would be right. But we're going to stop here. Like you could go on indefinitely. And that's something that if you take analysis, you'll learn is called a Laurent series. And this could just go on forever and ever. And you'll have something over x squared, something over x to the third, and it just goes on forever. We're not going to deal with that. We're going to stop right here because you say, well, x, I can't, there's an x there. I can't get just a pure 25 out of that. And another thing you see, and this is going to happen every single time you do this, is that this thing right here is in descending powers of x, and now you've exhausted your powers of x. They're not, you're done, right? That's as good as you get. So the same way that we did before, right? Remember when we did 4 divided by, or I'm sorry, 841 divided by 4. We had a 2 here, which gave me, and then I put a 1 here, and then that gave me a 4, and then we had a 1 remainder. And I said what we could do with that is say, that's the same thing as 210 plus whatever the remainder is divided by that number. And in that case, it came out to be 210 plus a quarter, right? Which was indeed 210.25. Well, that's exactly what we're going to do here. Our final remainder is minus 25. So the last term that we want, we're just going to say, well, plus, yes, minus, but you see what I'm saying here. This number, which is minus 25, divided by whatever that thing is there, x minus 2. And we are done. So I'm going to copy that back up top to see what it looks like, and then I'm going to check it. And that's going to kind of suck, but it won't be too bad. So I claim I've done my division algorithm here by polynomial long division, and I found that number divided by that number is this expression right here, which is x cubed plus 2x squared minus 5x minus 10 plus, or we could call it minus, in fact, I'm going to do that. I'm going to say minus 25 over x minus 2. Like that. Okay. Am I good to erase this work that we've done?
Uh-huh.
Okay, let's double check this. It's going to suck, and I'm sorry, but it's what we need to do this. I want to make sure that we have done this correctly. So in order to check this, I'm going to multiply both sides of this equation by that number right there. That's going to give me x minus 2 times x cubed plus 2x squared minus 5x minus 10 minus 25 over x minus 2. Okay. Now, one thing to notice, and this is normally not how we do this, but you see that guy in the denominator right there? That's an x minus 2. He's going to get multiplied by that x minus 2. So we could, in fact, what I'm going to do right here is the first step I'm going to do is say, well, why don't I distribute this thing into this one number and then into that one number right there to give me x minus 2 times that polynomial part minus x minus 2 times this last part, which was 25 over x minus 2. Like that. Does that make sense? Do you believe that I could do that?
Yes.
Yeah, I can. Oh, I can't. I just did. No. Yeah, I mean, that works, right? If this were just some number 5 minus 7, then I would take whatever that one number is and just multiply them in both ways. It's just that I'm trying to kill this denominator in an easy way, and I might as well go ahead and do it, which is nice because that goes ahead and cancels. We have x minus 2 in the numerator, x minus 2 in the denominator. They're done, which is nice. That just leaves me with a minus 25. Cool. We'll see what happens there. Now let's do the hard part. The x gets distributed into here and gives me what? The x times the x cubed gives me?
An x to the fourth.
Then what?
Plus x. Is that a 2?
That's a 2.
Okay, yes. X 2x cubed.
2x cubed. Then what?
Minus 5x squared.
Minus 5x squared. And then
Minus 10x.
minus 10x. Okay, we have distributed the x all the way in. Now let's distribute that -2 all the way in. So the -2 jumps in to hit that.
Minus
It gives me what?
2x cubed.
Minus 2x cubed. Then
Minus 4x squared. Minus 10x. Oh, plus 10x.
Plus, good, plus 10x. And then
Plus 20.
20. Okay, so I'm going to add those together. X to the fourth stays put. Plus 2x to the third minus 2x to the third is gone. Then what do these give me?
Minus 9 square x squared.
Minus 9x squared. What do these give me?
0.
A big 0. And then finally plus 20. But then, oh, this guy out there. So that right there, those two worked out to be this number. That is minus 25. So what's 20 minus 25?
Minus 5.
X to the fourth minus 9x squared minus 5 is indeed what we started off with. So I believe it. I have faith that we could just do this in the end. You take whatever your remainder is and write it as divided by whatever is in your denominator there. Do you believe it? I believe it.
I do.
It seems good. And it also jives with what we did earlier, right? Like we ended up with a 1 in the denominator and the thing we were dividing by was a quarter. So it's like, well, I could just write plus 1 over 4 and it's all consistent. That's what we're going to do. That's what happens when you're going along and you end up with a remainder. Okay. One last thing you need to know for your homework. Can I erase all this stuff?
Yes.
Okay. And I've decided to do something that we've kind of seen before. I wanted to do, yeah. So we're going to do this. Now, if we were in a different section, I would say, oh, wait a minute, that's a difference of cubes. There's a formula for a difference of cubes. And I could just use that formula and see if something cancels. And indeed, something would cancel and we would be left with our answer. But we're not going to do this because we're in this section. We're trying to practice polynomial long division. So we're going to do polynomial long division. This is where it gets really tricky. Because we know we're dividing by x minus y. So obviously x minus y goes out there. But what goes in here?
Okay. X the factor thing.
The what now?
Well, wouldn't you have? Well, you either x squared minus y, x cubed minus y cubed, or you have the x minus y and then the x squared thing.
Yeah, so
Right.
the thing is, when we're doing this, whenever we're doing this, we cannot have a factored form in here. It has to be pure polynomial.
So
right
wouldn't
now,
it be x
so what?
minus y cubed.
Yeah, x minus x cubed minus y cubed, but we're missing a whole bunch of terms. Yeah, so, and this is the tricky part, is that so we got to think descending powers of x, right? And so let's just do that part first. And we're not going to worry about the y's right now. If it's just if this didn't have any y's in it, it would be pretty obvious what to do. And what would we do? We would have an x cubed, then we'd have an x to what power?
X 0x to the second.
Yep. Then what?
Plus 0x.
And then we would have our constant term. But now when we have descending powers of x, we need to have ascending powers of y.
Mm-hmm.
So now there's no y's in this one. How many y's are in this one?
0.
That one had no y.
That one has one
One.
y.
And then how many y's?
2 y's.
Yep. And then finally,
3.
and it's a minus, so I have to be careful here. That is the trickiest thing right there. That in all of your homework, I think at least, that is, I don't think that they state it explicitly anywhere in the section that you need to do that. And then they just give you problems like that and expect that you should just, oh yeah. That's not obvious to me. Like this is tough, right? But that's what you're gonna do. Okay, so the rule is if it's just one variable, you have descending powers of that variable, no problem. If there's two variables like this, then we're gonna have to have descending powers of one, and then you just flip it. And you basically say, well, if I have descending powers of x, then I'll do ascending powers of y. And that's how you do it. And now, and I could double check that what we've written here is in fact that same thing. I've just accounted for these two missing terms right here. Okay, should be pretty straightforward from here on out. What do I need to multiply that number by in order to give me that number right there?
X squared.
X squared. So I'm going to put my x squared on top. He jumps up, parentheses, we'll do that. He jumps in and hits that guy to give me x cubed, as well he should. And then what do I have?
Plus x squared.
Plus?
No, wait, hold up. Minus x squared y.
Yes, minus x squared y. And hey, look at that. It was the next thing that happened. And it was the thing that we guessed might happen. Now you can kind of see why this has to be this way. If we're going to, like in our algorithm, do something to give me that and that, well, he's got to be an x squared. And then when he distributes in, well, you're going to pick up one extra y. And so you'll have an x squared times y, which is the thing that we didn't account for, the thing that we had to account for. So I feel pretty confident this is the way to move forward. Now, when I subtract that off, what do I get?
0, and then you get the plus x squared y.
Plus x squared y. Okay. Now, and let's just go ahead and drop all these guys. We get a 0 xy squared minus y to the third. Okay. Now, what do I need to multiply this guy by in order to give me this thing right here?
X. Right? Plus x.
Plus what?
X. Right?
Well,
Oh,
that would be just an x squared. What else do I need?
x y.
Yes, there we go. Let's just double check that. And this is the nice thing. I mean, like you took a guess, right? And let's just say that you had done that, right? Like you said, oh, it's x. And then you go and do it. And you say, okay, I multiply my x and I get x squared. And then I get my x and my y. Well, wait a minute. That doesn't take care of that guy. I'm missing something. If I just had a y there, oh yeah, I'll add my y right there. And so that's what I mean by checking ourselves as we move along. Like if you've done this part right, then the very first thing that shows up here should be exactly that thing right there. And so when I do this, xy times x gives me what?
X squared y.
Which it had better, right? Now I do xy times that and I get what?
X minus xy squared.
Yep, minus xy squared. And I feel even more confident because that is the same sort of thing as that is right there. So I feel good moving on. So I'm going to say, okay, into my parentheses, subtract them off, and what do I get?
You get a plus xy squared.
Plus xy squared. And then I'm dropping my y cubed down. Okay, last thing here. What do I need to multiply that by in order to give me that right there?
X y. No, wait, hold up. Y
Plus or minus?
minus.
Minus?
Wait. Yes, plus.
Plus, yep,
Plus y.
plus y. Let's try it. What is y times that?
X y. Oh, right. Y squared.
Y squared, there we go. So it's a nice thing, right? Like you could just guess, I think it's y, and then you try it and go, oh, I was off. And then, so then you could go back and modify it. It's one of the really nice things about doing it this way. So, okay, now let's try y squared. And what does y squared give me?
Xy squared.
Xy squared.
And then you have y minus y cubed.
Minus y cubed. I'm going to take that, subtract them off. Those guys are gone as well. They had better be. That should always happen. Your first ones. And then what about these guys? What do they give me?
You get a plus and minus, and then you get 0.
0. So we're at a 0. We should have no remainder. Therefore, this thing divided by that thing, or in other words, that divided by that should equal that right there. So I claim that that equals x squared plus xy plus y squared. And indeed, that's what our, I guess we call it a formula for difference of cubes tells us, is that, well, I love this, like we've just verified this by polynomial long division, but it should be the case that x cubed minus y cubed equals x minus y times x squared plus xy plus y squared, which is exactly what our formula tells us, right? Like if you just gave me that, I would say, well, that to the first power, that to the first power, that squared, that times that, which is xy, that squared, and then I'd go SOAP and say same sign, which is a minus, the opposite sign, which is a plus, always positive. And yeah, that works. But let's just really beat a dead horse here and just multiply them through. We're going to say, okay, we're verifying this equals that. And so I'm going to distribute my x's first, and I get x cubed plus x squared y plus xy squared. Double check, yeah, x went in, x went in, x went in. Yeah, that's good. The minus y comes in, and I get a minus y times x squared is minus x squared y. The minus y jumps in here to give me a minus xy squared. The minus y jumps in here to give me a minus y squared. Add those guys all up. My x cubed stays put. That guy's gone. That guy's gone. And I'm left with my minus y that should have been a cubed minus y cubed. X cubed minus y cubed is equal to that. Therefore, we could say yes. Our first thing is true. That divided by that is equal to that. Does that make sense?
Yeah.
Cool. That's all this is about. This is synthetic, or no, not synthetic. Sorry, I'm looking at the wrong thing. This is polynomial long division. Pretty straightforward. It gets really ugly when there are fractions involved.
Yes,
I don't think there are any fractions in any of your homework, which is nice.
Oh, good.
I'm kind of bummed because I wanted you to have to do some fractions, but
No, it's okay.
you
It's
got
fine.
over it. You
It's
get
fine.
over easy. So, but this pretty straightforward, but it's really, really good to go over this and do it a bunch of times.
Yeah.
Because it's gonna show up in the future. It's useful for a bunch of crazy different things that you wouldn't think it's useful for.
I think honestly, this might be easier than factoring.
Yeah. Oh, yeah. It definitely is. I mean, it's a lot like, we had a matrix to do. This is much the same way. This is how we had a matrix, which abstractly helped us to do something. This is another method, it's like a matrix. I mean, what does this bar mean? Like it's the same way, like when you put something in a matrix, it's like, what does that mean? Well, it's just a nifty tool we could use to get, to do various things. So now, having said that, the next section is called synthetic division. It's basically, they take this and boil it down to like really mindless work. And that's great if, and it says it, I would like you to go ahead and just read over section 6.5. It's called synthetic division. Read over it. We're not going to touch it because it only works when you have a polynomial. Let's just say this guy, divided by, and it has to be a polynomial, a monomial with, in other words, it has to be in this form here. It has to have nothing in front of the x, and it has to be, it's called a linear term. And why is it a linear term? Well, because y equals mx plus b, right? It just has some constant in front of the x, some constant. That constant has to be a 1, and then it's plus some constant value. And synthetic division only works when you're in this case. And I don't want to go over it. I don't even want to talk about it because what we just did is going to work just fine. Like everything that we did is going to work just fine. And what I find is like, I've never done synthetic division again since I did it in class. And it's every single time I've heard it, I've thought, oh, wait, what's the rule? There's a certain, you could use it in certain cases, but you can't use it in other cases. Is this one of the cases where I could use it? And so rather than having to worry about that, we're not going to cover it because it's a lot simpler, but it takes maybe an extra minute to just do the polynomial long division. So just do the polynomial long division, but do read about it and you could see like that. Yeah, it simplifies things a lot, but only in a special case, which you're never going to see. So whatever. All right, so your homework. Chapter 6, section 4. This is all on one page. I think it's all on that one page, 262. Numbers 1 through 29. What? 1 through 29 odd. And then numbers 31 and 32. Okay, no, I'm sorry. For 1 through 5 only. So 1 through 5. No poly long division. You do not need to use polynomial long division on numbers 1 through 5. There, that very first case that we did where we just split up a fraction into 3 fractions, that's what you're going to do with those. Too easy, right? Everything else, use polynomial long division. Ignore the instructions for 1 through 13. Or no, I'm sorry, for 9 through 13. Ignore instructions, just do polynomial long division.
Okay.
Or make sure I do that. I'm sorry. On 9, and because you will have just done this 3 times. On number 9 is just like these, where you could split up a fraction into multiple fractions. Do that. That's fine. So everything else, do polynomial long division. That should be it. Number 31 and 30. Oh, yeah. On 31. 31 is a challenge problem. And you are, where are my notes? Okay, on number 31. You will soon end up with a coefficient that looks like this right here. Rewrite it as negative k plus 2. And then just pretend that this is a number. For the rest of the time that you do this problem, just remember, k plus 2 is just a number. We don't know what number yet. You will find out at the end. That's what the problem's all about. You will be solving for k, but in the end, so throughout the whole thing, just remember that k plus 2 is just a number. Pretend it's 5 or something, right? Like, just go along with it. But yeah, that's your hint for number 31.